Hello everyone. In this tutorial we will have a first introduction to Solidworks Motion in order to perform motion studies. For this purpose we will use a simple ball drawing example. As you can see in the animation, this example simulates a ball drawn with an initial velocity at a given elevation. Due to gravity, the ball will travel following a parabolic trajectory and bounce back a few times when it hits the ground. During the video, I will show you how to create a motion model to simulate the ball motion, run a simulation, and analyze the results. Finally, we will use particle dynamics theory to calculate the position and velocity of the ball in order to compare the simulation results with the hands-on calculations. So, first of all, we will start looking at the physical model. To define the model, we need to know some parameters. In this case, such parameters are the dimensions of the ball, it means the radius of the ball, the initial velocity, the initial elevation, and the gravitational acceleration. Now we need to consider that the unit systems used for this video is IPS, inch, pounds, seconds. To simplify the model, we will have some assumptions. First, the ball and the ground are rigid. And second, a coefficient of restitution, which is 0.75. This coefficient is assumed considering that the bounce velocity will be 75% of the incoming velocity. Okay, so first of all, we will create the assembly, a new assembly. Import the ground. And now we will move the ground to make its origin coincident with the origin of the assembly. Modify the units. And now we can import the ball. Okay. At this point, I want to put the ball in the position. So I want to put the front plane of the ball in the front plane of the assembly. The same for right. And now I want to define a distance between the ball and the ground. So I will change here, giving a dimension between the top plane and the top plane of the assembly. And I will write with 100. Okay, now the assembly is completed. I will save. And save as lesson 1. Okay, now we can start creating our simulation. So we will change to motion study and check if we have loaded the add-in. So bear in mind that when the model is already loaded, we have 3 options. The last one is motion analysis for simulations. So first, we will add gravity. Here we can define the direction of the gravity while using y direction. And we will set some properties of the study. First, we will change the frames per second to 200. Activate use precise contact option and reduce the accuracy here to 0.001. Okay, now we can add the velocity the ball, the initial velocity, define the direction, x direction, and the magnitude. Okay, now we will reduce this time simulation to 3, and we need to erase some restrictions. That means the restriction of the movement in this plane and the distance. So we will suppress these two restrictions, and we can make a first run. So you can see the ball crosses the ground. It is owing to the fact that we didn't define a contact. So we need to define now a contact between the two bodies. To do that, add contact, define the bodies, and choose only the option restitution coefficient, 0.75. Okay, and let's try again. Calculate. Now we have movement. Perfect. Now we can see this movement. We can see that trajectory. So we will add a plot. To add a plot, we can just make right click in the ball and create motion plot. We will add a displacement, velocity, acceleration, and a trace path. To select the trace path, it's important to know that trace path only works with points. That means that we need to see the point, the center of mass of the ball, or the origin of the ball. So we have hit the point and we can see the trajectory. Great. Now we will create another plot. This plot will be for the center of mass position and in the y component of our ball. Now we have here this plot, and we can see here what is the position and the height of the ball at each second. Similarly, we want to see a new plot for velocity in the same component for the ball. And we have a plot for the velocity. We can create a plot for the velocity in the x component, but the result is a constant line. This is because in this kind of motion, the velocity in the x direction is always constant. So we will use only these two plots. Now we can export these plots to Excel. To do that, right click in the plot and export spreadsheet. That will create an Excel file with the plot and with all the points of the plot. So we will change here the number to see more clear, and you can see here the plot of the position of the center of mass and our points. The same for velocity. Great. So now we already have our simulation. Now we need to validate these results to ensure the accuracy of the simulation.